Okay, so now we have all been calculating or we're looking at the rules that governs ionization, um, also known as the octet rule. So now we are going to apply all of that information from last class into some calculation. There are two things we are going to be determining today is to determine if an element is going to lose or gain electrons during ionization. And the second thing is to determine the charge on the ion that is formed after ionization. So here is an example that we're going to start with beryllium, Be, and as you can see, beryllium has an atomic number of 4, which tells us that beryllium has 4 electrons and 4 protons. So therefore, the electronic configuration of beryllium will be 2, 2. So that tells us, or it shows to us, that the last shell of beryllium has 2 electrons. These 2 electrons, that means that this element will be losing 2 electrons during ionization. So now we know it doesn't gain because we have to gain 6 electrons to get 8 here, or lose 2 electrons to gain a full outer shell. So therefore it will lose 2 electrons. So next thing we're going to look at is charge. So we'll start with the charge on the atom itself. And as you can see, it has 4 protons, which will be 4 positive charge, and it will also have 4 negative charge originally, but it has 4 electrons. So it gives it an overall charge of 0. Gives it an overall charge of 0. So therefore, let's look at the iron. So it still has 4 positive or 4 protons, plus it has 4 electrons, but it's going to lose 2 of those electrons, and we're going to determine the overall charge X. So these 2 electrons that are here comes on the 2 electrons that is being lost. Okay, so let's put this in terms of charges. So 4 positive plus 2, 2 from 4 is going to give you 2 minus, because electrons are negative, and so 2 minus is equals to 2 plus. So therefore the charge on beryllium will be 2 plus. Remember, you always write the number first, then the charge. All right? So let's do a second one. Let's look at boron. Now, boron is the next element, and as you can see, it has an atomic number of 5. This tells you that the boron has 5 electrons and 5 protons. So the electronic configuration of boron is 2, 3. So it shows here that it has a valency of 3. So because of a valency of 3, this atom will be losing, once again, losing 3 electrons. Okay, so now we have determined that part of the equation, the what whether it's losing or gaining. The next one is that we're going to look at the charge. Let's start with the atom. As you know, atoms have a charge of 0. This is because it has this one in particular have 5 positive because 5 protons plus 5 negative because of the 5 electrons that it has. So it has an overall charge of 0. What on the iron now you still have 5 protons plus you have 5 electrons, and you're going to lose 3 of those electrons. So your minus 3 is going to be equal to X, which will be overall charge. So in terms of positive and negative, you will have 5 positive plus 2 negative. Where did I get that 2 from? May remember that these 3 electrons are taken away, are removed from the 5 original electrons that the atom had. So you end up with a total of 2 electrons, which will be 2 negative. So this will be an overall charge of 3 positive. So the charge on boron will be B3 plus. Okay, there you go. Let's do one more. One more. Here we go. So we have bromine. Now bromine is outside the first 20 elements, so you would never get this one to do in an exam or a test, etc. But since I can do chemistry, I'm going to show you guys this one. So boron has an atomic number of 35, which makes it have 35 electrons and 35 protons. All right. So the electronic configuration of boron, bromine, sorry, will be 2, comma 8, comma 18, comma 7. You will see that adds up to, to, to 35 in total. So therefore, as you can see, the octet rule still apply. 7 electrons on the final shell, which means that bromine only need one more electron to make and 8 electrons on the outer shell. So therefore, in this case, bromine will be gaining 1 electron. All right? So we know that. Now look at the charge on the atom. The charge on the atom is this. 35 proton plus 35 electron, which is 35 minus, will give you an overall charge of 0. So let's look at the iron now. So you still have 35 protons plus 35 electrons plus, because you're going to add one more electron, give you what? So now you have 35 in terms of charges, charge 35 plus, or plus 35, added to 35 plus 1 is 36 negative, to give you a grand total of 1 negative, because there's more negative than positive in this case. So therefore, the overall charge of bromine ion, the bromine ion is called bromide, okay, it will be 1 minus. Last one, okay? We have here oxygen. Oxygen have an atomic number of 8, which means it has 8 electrons and 8 protons. So the electronic configuration of oxygen will be 8, 6, right? So the chart, so as you can see, oxygen here will be gaining, oxygen will be gaining 2 electrons. Why 2? Because you need only 2 more to make a full outer shell. You add 2 to 6, you get 8. Octet rule still applies. So let's go down to the determining the charges. Okay, so originally oxygen atom will have 8 protons and 8 electrons, so give an overall charge of 0. So for the iron, you have 8 protons, okay, plus 8 electrons, plus you're going to add 2 more, as seen here. You're going to be adding 2 more, so it's 2 electrons equals X. All right, so that means in terms of charges, you have 8 positive plus 10 negative is going to equal overall charge of 2 minus. So there is more negative. So the charge on the oxygen ion, which is called oxide, is 2 minus. So I hope this was enlightening enough for you. And so you can now do some on your own. You can do these on your own. Okay, potassium, magnesium, aluminum, nitrogen, sulfur, and chlorine. You'll do these on your own following the same steps that was outlined in the example shown. So I hope And if you don't understand, you can always ask questions or you can always refer back to me. All right.